I don't get into the depth of each scientist's contribution. What I will do is I will just highlight the contributions, in which area they have made contribution, so that you can appreciate their work, identify and appreciate their work. Okay. So what you will get benefited at the end of this session is you will be able to identify and appreciate the important scientific contributions of some of the ancient Indian scientists. I told few I will be covering. Identify and appreciate the important scientific contributions of some of the modern Indian scientists. Okay. Some you might be knowing, but some you might not be, or you might have heard just the names. Okay, and not exactly their contributions. Okay. Let me begin with this. How this scientific thought starts in human beings. A baby comes out of mother's womb. Okay. When it sees the bright color, it starts crying. Okay, it starts from there. When it looks around and sees a bright world, so why is it so? Why is something new? And after that, every stage of the kid, if you observe, you can find they will ask a lot of questions. If you interact with the kids, you can observe for each and everything they will ask question. Why? What? But unfortunately, these elders, we will lose this questioning attitude. I don't know how many of you will ask such questions in the classroom. The number, if you cross-check, nearly 96% of the kids under the age of 5, they will ask a lot of questions. But by the same kids, by the time they reach to age 18, 20, only 2-3% of kids will have that attitude of questioning. So where it goes? Probably, by hearting for the sake of examination, or parents telling, hey, chup, okay, or your teachers telling, Kutko, I will tell you later, and that I will tell you later never comes. Okay, it may happen in many cases. That is how over the time, repeatedly, when a kid listens to this in school, colleges, at home, usually parents nowadays both husband and wife will be working. By the time they come back to home, they will be tired. They will not be having patience to listen. Some of the parents might not be having that. They will listen to the kids because they need to care. So what happens in majority cases is they get tired, and when kid asks questions, they will tell, okay, chalo beta, I will explain you later. Keep quiet. When they irritate too much, shut up. So this will happen. So repeatedly when kid listens to this, they will slowly stop asking those questions. That is where by the age of 20 this transformation will be there. They want to ask, but somehow that inhibition will come in them. I should not ask questions. They get irritated. Now my teacher may scold me. My father may scold me. My mother may scold me. These kind of inhibitions will come. But generally, we are made, human being is made of these questions. Always our research is developed on these questions. What was given to us from our ancestors? What they knew earlier? How did they know? How did they know? For what purpose they found that particular device or particular invention? Who are those guys, those scientists, what I am referring to? Okay? What are their legacies? What are their leftovers? What is the relevance of that past today? Remember, history, it is there in schools. We study history. Why do we study history? We are learning lessons from history to improve today as well as prepare ourselves for tomorrow. That is why history is very important. We need to look at that historical perspectives, what has happened in the past. Okay. Some of the statements, if you look into, this is a statement by Aristotle. Don't get offended. At that time, the era was dominated by men. So he has used all men by desire to know how to, desire to know. Men. Women are also there. Everybody could get questions. It is not just men. Correct. Don't you think you will get questions? You get a lot of questions, right? So at that time he has made statement, don't worry, you are there in that. Okay? You know Aristotle, who is Aristotle? A Greek philosopher, 2000 years ago. Okay? A student of, he was a student of, is it Socrates or Plato? Sir. I think you just check that number, I know the name. Okay? There is another statement by Kautilya. Who is Kautilya? Chanakya, Vishnugupta. Okay? During the period of Chandragupta Maurya and later Ashoka, Bindusara and Ashoka. Vijnana Deepena Samsara Bhayam Nivartate. I am not expert in Sanskrit, but I have discussed with Sanskrit scholars to understand each statement when I wrote the book on ancient Indian science. The meaning is the enlightenment from science will remove the fear of the world. If you know the scientific merits, you will not get afraid of. Now, whenever you go out, a cat comes in front. There is prejudice. Something will happen to me. So you stay back and then after a few minutes you will leave the house or any other program. But if you know scientific merit, you will not believe into that. There is no problem. No, it doesn't. See, many of the accidents actually happen due to dogs, not due to cats. Many road accidents in Bengaluru also. That is because of dogs, not due to cats. But we are afraid of cats. Some prejudice is put into our mind because of non-scientific beliefs. Okay. So if you know the scientific merit, you don't bother. You just go ahead. Okay. So enlightenment of science is very, very important. So if you look at the history of science, the history of science is the change of natural knowledge claims over the time and also the causes for these changes. Over the time, how the changes have happened, why those changes have happened, that is recorded in the history of science. Okay? It's a very vast field from Plato to NATO. NATO now also is coming, Second World War, that NATO word you heard. Third World War. Now also you are hearing from yesterday, right? NATO. So this field embraces many scientific traditions from algebra to zoology. Why I have used algebra to zoology is A to Z. All fields, it will cover all fields. Okay? Today science is tomorrow's history of science and it is dynamic in nature. It never stops. You take human evolution. Science is also evolved with the human being. It never has stopped. It is on continuous basis. So while teaching research methodology, I use this. Research is neither a first step nor a last step. It is a continuous step. So a long period of time will be working in the path of research. So in the early stages, the social science was developed based on the natural science model and were recorded in the name of traditions. Okay. There is very complex, intersections between science, technology, and philosophy. Earlier, this word science, it has come in last 250-300 years, not much old. Earlier, they were using the word philosophy. Even for, you can read the earlier books, natural philosophy. That means actually natural science, including chemical, biological, and physical sciences. That is natural science. Okay, they were calling it as natural philosophy. And the research was based on inductive reasoning and deductive reasoning. What is it, inductive reasoning? They will start from specific and get something generalized theories out of this inductive reasoning. And for deductive methods, they will start from the specific, start from generalized theories and they get into specific. Simple example, I'll make the statement, all vaccines cure diseases or prevent the diseases. Okay? COVID-19 vaccine prevents COVID-19 spread. There is a small difference. In the first statement, it is a very generalized statement. Okay? That generalized statement is used in finding solution to the COVID-19 problem. Okay? So, inductive and deductive methods of finding solutions to societal problems is followed from the period of Aristotle. These words have been used at the time itself. Okay. Indian science in many a times recorded in the form of traditions and Puranas, sometimes mouth-to-mouth transfer of knowledge will be there. These Vedic mantras have been transferred mouth-to-mouth majority of the cases. Okay. Many of the time you don't find the text, but people still they chant mantras. Okay. Always we don't need to believe Purana is non-scientific. There are non-scientific beliefs in the traditions what we follow, but that should not make us believe that everything is nonsense. Okay. As science graduates, we should look at what is the scientific merit in those beliefs. Okay. So based on the scientific beliefs, we have to follow the truth. Okay. That is the basis for science. Puranic literature is encyclopedic in nature, includes various topics, very vast. It has covered, from A to Z. Okay. Secrets of technical skills, stories in the recorded history are not always kept separate, but there was, they have been with some of the people, kings and some business class. So these scientific practices, they were being protected by kings and some business class people. If you look back into the history of human evolution and scientific progress, it starts from Babylonia and Egypt and Indus Valley civilization. It is originated in Africa and then moved towards Asia, then towards American countries. In between, Europe also is there. Later on, these activities moved towards Greece. These Greeks are people who brought the theoretical basis for the systems what we observed. Okay. But in some of the European countries, including Rome, at that time there was no scope for science. A lot of restrictions. Whatever churches were told, people were believing, not the scientists. Okay. There was a lot of hesitation for scientific community to come forward and tell the truth, and people were not accepting. But later on, slowly it got changed, particularly after 1650s. Okay, when this industrial revolution occurred through the Europe. Okay. So from the Greece, again the scientific activities moved back to the eastern part. Okay, Syria, Persia, India, and China. Heavy number of scientific activities were there. And then from the east, again they moved back. I will show the path, how human evolution has moved from one place to another place. Similarly, whenever human population, wherever it has moved over thousands of years, scientific evolution also moved along with the human. So this is where it started, from African region. Okay. See these blue dots, what is shown here, okay, here. Wherever that blue dots have gone, they are estimated based on carbon dating of the fossil fossils that were available during the excavation. So this path, what is shown is the movement of human being, from time to time. If you look at this is somewhere it started from 1,95,000 years ago. Okay, the carbon dating has shown this result. Human activities were identified here, and around 1 lakh years ago it was identified here. And similarly, at different stages of timeline, you can observe it is moving into the American region, and again they go back with modernization. Again they will come back with severe, intensive scientific activities. Okay, so the movement is recorded. Recorded the migration of early humans. You have seen this Bengaluru Mukamika temple. How many of you have seen? Okay, if you go there, you can observe this. It is 2,300 years old. It is the model of Indian metallurgy. 2,300 years. You may read in the newspaper, or you may listen to electronic media in TV news that when a minister goes, the bridge collapses. When a minister goes for inauguration, bridge collapses. It has happened many places. That is modern technology what we have, the metallurgy what we have. That means the materials what we are producing are of inferior quality. But what was there at that time, this is made up of some kind of iron. In 2013, I think one paper has been published by IGCAR scientists, Indira Gandhi Atomic Research Center, IGCAR Kalpakam. Those scientists, along with NIT Surapal, these scientists, they took small samples and all modern equipment they use to ascertain what is the composition. They have found the composition of this material, and till today we are unable to produce such kind of materials. Another example is this is close to 1,700-year-old iron pillar at Qutub Minar, Delhi. Okay, that is also such old one. Okay, what kind of technology they had at the time? Remember, it is said that this materials production of processing was done by tribals, not by engineers. That means this tribal knowledge was such superior to make such kind of materials. And India had very good number of iron blast furnaces in earlier times than any other countries. So we were very rich in metallurgical sciences earlier. Sushruta, you might have heard the name. He is a doctor. Somewhere 2,400 years ago he lived. He was a physician and he is known as Pitamaha of plastic surgery. The first recorded documents available that he is a famous plastic surgeon. Okay. See, what was happening is this plastic surgery started during that time. Kings or the rulers, they were punishing people who did crimes by cutting the nose. Immediately these criminals were running to this doctor, and he was taking some portion of the cheek and giving a shape, okay, here to the nose, along with some estimadu, tisara, and some more Ayurvedic formulations, along with turmeric. And some 15 days treatment were given, and they were able to recover those, the last nose. So that kind of plastic surgeon, surgery was being done at that time itself. Okay. So he learned this medical science from his guru Devadas Dhanvantari. He had the knowledge on anesthesia and surgical procedure along with medicine. Reconstruction of fractured bone, cesarean, you call C-section, removal of stone from kidneys, cataract surgery. Can you imagine? Yes, performed cataract surgery at the time. Okay. Of course, different names have been used at the time. Now, just I have, for sake of understanding, I have put these names. Okay. Some of the specialized skills what he possessed at that time. So So his book, what is called a Sushruta Samhita, he has recorded all these, treatment methods, surgical instruments, what he was using. At that time itself, one medical equipment he has used and mentioned in that book. He had mentioned somewhere 210 number of bones in the human body, but today, scientific evidence is there 206 bones. What facility he had to ascertain 210 number, which is very close to 206. Now we have all modern equipment. Okay, so that kind of experience, even if you go to old doctors, they will just see the pulse of human being and advise medicine. They will understand what is the problem and advise medicine. Very senior doctors. But modern doctors, they need all diagnostic results today. Okay, still you don't get 100% result. Okay. So he had classified 7 layers in skin, whereas modern science classifies only 3. So where is 7, where is 3? So that kind of sophistication he had in terms of knowledge. Okay. His students were taught with a dead body before they actually performed operations on human beings. That means what we do in the medical college. Students will be taken to the operation theater where a dead body will be dissected and that will be shown. Each part, how do we analyze, is shown by using the dead body. It was used at that time. The method was used at that time only. Okay. Sushruta Samhita has been classified into 2 divisions. One is Purva Tantra, another one is Uttara Tantra, which cover extensively on the treatment of elderly, children, eyes, nose, throat, toxication, and psychiatry as well. Okay, vast medication and treatment methods he has covered, and also it covers 84 chapters covering diagnosis, Roga Nidana, treatment of 1000+ illness, 700+ medicinal plants, and the preparation procedures to produce such medicinal extracts have been written in that Sushruta Samhita. Charaka is another person related to Ayurveda. He lived in 1st century BCE, that is close to 2100-year-old history this is. He had written treatise by the name Charaka Samhita. It covers 120 chapters where 30 chapters reserved to general medicine, 8 chapters for reasons for diseases, 8 chapters for dietetics, food related, how to consume food to avoid diseases, 8 chapters of physiology, embryology, 12 chapters of diagnostics, 30 chapters of treatment methods, 12 chapters preparation procedures, that is medicinal extracts, 12 chapters of treatment of diseases. Food digestion, immunity of human body are explained based on Tridhatu, that is Vata, Pitta and Kapha in our body. Whenever there is a variation in these 3 elements, we are prone to diseases. Okay. You might have read or listened to this statement. They were using bhasmas for the treatment. In Ayurveda now also they use it. But earlier time, they have also used bhasmas of mercury, lead. And today modern science, what it tells, lead is toxic, mercury is toxic. Okay, it directly affects the brain as well as our nervous system. Okay, bhasmas are nothing but oxides of these metals. Various metal oxides have been used, but these toxic metal oxides have also been used in a particular concentration. Their preparative methods we are not still understood, because we are staying away from Sanskrit. We don't want to read Sanskrit, we don't want to understand Sanskrit. Okay, we are allergic to other languages. Okay, you don't need to be so conservative about languages. If you know more languages, there is nothing harm. It is actually advantageous for you. Okay. He has classified diseases in three categories: physical, accidental, and psychological. They arise due to overuse of indriyas, panchendriyas, we call them. Overuse, underuse, and wrong use. All the three will cause diseases. Okay. If you watch too much content on mobile, you are overusing your eyes. Okay. Slowly, what happens? Your eyesight will come down. Your ability to read small fonts will get decreased. Okay. And your sleep gets reduced. That radiation that comes out, to your eyes, it will affect your sleeping pattern, and that sleeping pattern affects your digestive system. Okay, so a lot of interconnections are there we don't understand. If a parent or teacher says don't you overuse the mobile, you don't listen. This fellow, I know, they're very good at using. You are all very good at using these gadgets. Variation in weather also causes health issues. Wrong use of intelligence. Many a times we do that. So wrong use of intelligence for doing bad things. Okay, that will affect our mental behavior. In turn, that is connected to our physical body. Illness. Okay, it will bring illness also. Charaka modernized Vedic medical knowledge on scientific merits, and he connected theoretical teaching with practical training as well. Similar to Sushruta, he also followed. And in Charaka Samhita, he has cited several times about Sushruta Samhita. Okay, like we cite our earlier research work when we write our research articles. No? Similar to that, he has cited several times the Sushruta's work. He had organized several conferences of experienced doctors. Okay, where a lot of ideas were exchanged at that time. Now also we follow the same. Okay, at that time they were having discussions. May not be in this kind of auditorium, under the trees. It will happen. Knowledge exchange can happen everywhere, even for a cup of tea or coffee. Okay, it can happen. Need not be only inside the classroom. He identified psychological effects on diseases and psychological effects on the treatment of diseases. Both psychological effects will be there on diseases in the cause of disease. Also, psychological effects on the treatment. How do we recover is also based on our mental status. Okay, that is why positive thinking and listening to good things are very, very important. Right? If you recall, your elderly Ajis, grandmas, they will be telling pregnant women, you listen to mantras, you read stories about gods. Okay, why do they tell that? So these negative energy should be kept away so that the health of the baby is in good condition. So there are things which we need to follow. Okay, every time we don't need to tell Aji that you don't know anything, leave me alone. Okay, that's not the right solution. Okay. Charaka also advised personalized treatment, as treatment methods were differed from person to person. That's what we are observing now. Western countries started personalized treatment. Now India is moving towards that personalized treatment. It was there in ancient India also. Right. So the next contribution is from Vagbata. Is from a 1,600-year-old history. He was part of Sindh. Now this part is in present Pakistan. His contributions are recorded in Astanga Sangraha and Astanga Hridaya. Okay, these two books covers whatever he has done, the work related to medicine, treatment of diseases, and the medicines that were prescribed at the time, what it says is 80% of diseases can be cured without doctor. That we observed during COVID situation. We were not going for small things. It was getting cured. Okay. Remaining 15% diseases require doctor's attention. Okay. Somewhere he has used 2170 poetical verses in the form of slokas. He has explained Ayurvedic medicine, surgery, gynecology, pediatrics, hygiene, and special emphasis is also given on arthritis and neurological disorders. A lot of areas they have covered at that time. He has emphasized more on internal medicine, and he also had interest in metallurgy. Okay. Towards last phase of his life, he lived in Kerala, and that influence still is there on Kerala Ayurvedic medicine, for bit of medicinal influence. Coming to agricultural practices from Ayurveda, India is well known for its agricultural practices. It's not now. Now a lot of universities have come, universities of agricultural sciences. These ideas what farmers were practicing based on experience, transferred from one generation to another generation. And if you look back into the history, there was one person, Parashara. If you read the history, two Parasharas you will find the names. One is Parashara during the Mahabharata period, is the father of Vyasa Maharshi. The next one comes to 4th century BC, that means somewhere 2400 years back. Okay, this Parashara. Mahabharata somewhere 5,500 years back. Okay, that much old. In that also, one of the chapters, he has written Parashara Smriti. Vyasa Maharshi's father Parashara, he has written this Parashara Smriti. One of the chapters he has covered on agriculture. But this Parashara, he has written Krishi Parashara. All the chapters are relevant to agriculture only. Okay, what he has covered? He has covered the in terms of 243 shlokas, weather prediction, rain prediction. Now we have a lot of statistical models. Statistics is becoming very important in all the fields. Okay, weather prediction, rain prediction, based on the calculation of planetary motion, wind direction, and speed. Okay, the annual rainfall he was predicting at this time. He considered animal husbandry as integral part. Now we have started ministries, animal husbandry ministries, both at state level as well as central level, to promote that. Okay, animal husbandry. So it is essential part of farming. Okay, so if you have animal husbandry, one type of income you are getting, and the milk and other dairy products generated out of that we can consume and keep ourselves healthy. And also the manure what we get from these animal husbandry is very beneficial to produce good amount of grain. You can increase the yield by using that manure. So those practices have been mentioned in Krishi Parashara at that time itself. Okay. But nowadays, if you go to villages, how many of you are from villages? I am from village. I don't hesitate in telling. I am from Chitnikere, Chitradurga Taluk, Chitradurga district. Okay. You should not feel hesitation while telling about village man. Be proud. Okay. What happens? I have observed in our village only. I will take the example. Their thought process is like this: if I have cow or buffalo in my house, that will restrict my movement. I want to roam around, that will restrict my movement. This kind of thought process is there. Now they are using a lot of machinery. JCBs have come into the farming, and these power tillers, tractors have come into the farming. So those earlier scientific basis what they had framed in farming are slightly going away. For example, they were having bunds for small areas of agricultural fields. small pieces of land, agricultural bunds you can observe, where trees were also grown. What was the reason? These bunds were avoiding the movement of top layer of soil, where microorganisms are there in crores. Okay, soil microorganisms which are essential for soil fertility. If the microorganisms are there in good quantity, the humus produced by these microorganisms, it will create a lot of manure. So, soil fertility will be increased. The organic content of the soil will be more. Now, pre-independence, 3% of carbon was there. Now it has gone to 0.3%, 10 times decrease in last 70 years, which is not good because we started using a lot of fertilizers, chemical fertilizers. We started using a lot of pesticides, which is not good sign. Okay, so we need to preserve our soil in good condition for the next generation, where animal husbandry was taking care of that. The soil fertility was increased. The trees in the bunds of these agricultural farms, the leaves that falls onto the soil, they were becoming manure. So people now they want to see vast field, big field, instead of a small portions that were segregated by these bunds. They want to remove. Use the GCB, remove it, make flat land. Now what happens? The wind is blowing very fast. It will carry away the top layer of the soil. 3 mm of the top layer of the soil, if it is carried, a lot of microorganisms will get washed away, both by heavy rain as well as by this wind, which is not good. So soil fertility will go down. And also water holding capacity of the soil will go down if organic content is less. Okay, you need to supply more water for producing the food grains. See, all these interconnected problems are there. They were taken care at the time. But now, using machinery, we are spoiling that. So one needs to be very, very careful, just for the sake of making, big farms. Okay, we should not remove those kind of bunds and trees that were grown in the bunds. So manure, it will improve soil fertility and yield of crop as well. So a lot of seed preservation techniques and the use of quality and natural pesticides were practiced at that time itself. Medicinal plants, growing was explained in that book. In another book, it's the second book, Ruksha Ayurveda, there is another contribution of Parashara. So many times what is the contribution of India? Big zero. Yes, it is a big contribution. Without zero, you couldn't have counted billions or millions, right? So if you place that zero in front of numbers 1 to 9, then only you can have all these big numbers. So the contribution is from Aryabhata, a great mathematician who lived 1500 years ago. So he introduced the symbol of zero along with 1, 2, 3, 4, 5, 6, 7, 8, 9. These 10 symbols are ruling the mathematics now. Okay. The concept of zero and its integration into the place value system enabled one to write the numbers no matter how large by using only 10 symbols. We can write those numbers, even several billions you can write. Okay, you can quantify. First of the major mathematician, astronomer is Aryabhata, from the classical age of Indian mathematics and Indian astronomy. His works include Aryabhatiya. He wrote this book in the age of 23 years. You are also 23. Not it? Oh, you are very shy. Okay. It may be the truth. Okay. So that means in next 4 years you are going to write one book. See, at 23 years he has written Aryabhatiya. Lot of mathematics. Okay. And Arya Siddhanta. Okay. These two treatises emphasize lot of mathematics in it. What is explained? he has explained Chakravala method. It's one portion I have just picked. We use this. How many mathematics students are there? You might have read about Pell's equation in that mathematics. Okay, that mathematics is a quadratic equation, indeterminate quadratic equation, which has multiple number of solutions. Okay, this equation is explained as Chakravala method at this time. Okay, now we are using Pell's equation, which is 400-500 years old. Okay, so Indian mathematics was such strong at that time. We have not, carefully looked into what is there stored in Sanskrit. This method was, established to obtain integer solutions. Was developed by Brahmagupta, another mathematician, who lived after 100 years of the period of what is it? Aryabhata. Okay. He is also another well-known mathematician, Brahmasputa Siddhanta. He has written this book, Brahmasputa Siddhanta, Brahmagupta. Jayadeva is another mathematician, 1000 years ago. So he has generalized different, equations, mathematical equations, which is explained in Bijaganita treatise. Okay. So later it was further defined by Bhaskaratu. Bhaskaratu is, again well-established mathematician. He is from Karnataka, Bijapura. Okay. I think probably during the period of Sharana Parampare, Basavanna. Okay. At that period, he had lived in Bijapur. He had written Siddhanta Shiromani, which includes 4 chapters. Leelavati, believed to be his daughter's name. Bijaganita, Goladhyaya, talks about astronomical calculations. Grahaganita, again astronomical calculations. It was written in I think modified. I have used wrong word here. 1628. It's modified versions. In Leelavati, many of these mathematical formulations are given in 277 poetical verses. Most of the time they have used the shlokas, to talk about mathematics. Okay. Mathematical concepts on mensuration, geometry, indeterminate equations, Pell's equations are explained well in Siddhanta Shiromani. Surya Siddhanta, Karana Kutuhala. Karana Kutuhala talks about, again astronomical events and their calculations. They are the other works of Bhaskaratu. Okay. Varaha Mihira is a well-known astronomer, mathematician, and astrologer. He predicted king's son's death well in advance. Okay, and the death occurred on the same day what he had mentioned. Okay. Initially there was a lot of resistance for his predictions, but later on, after observing, the king accepted his, the way he was predicting. Okay. Even though they took a lot of precautions upon his advice, but that fellow didn't survive. Okay, it was killed by one of, I think, this boar will come, no? It was killed by that animal. Okay, that is why that Varaha Mihira, Varaha, boar. Okay, his writings are written in Panchasiddhantika, Bruhat Samhita, and Bruhat Jataka. It talks about this Jyotisha. Okay, Bruhat Jataka. It talks about Jyotisha. Nagarjuna is a very good, metallurgist or alchemist at that time. He lived in Gujarat in the district of Somanatha. He had done a lot of work in the field of metallurgy, where his findings on metallurgy are recorded in Rasaratnakara, Rasarudaya, and Rasendra Manjari, 3 books. Okay, in those books he has written on metallurgy. He has also focused on Ayurveda, that is mentioned in Arogya Manjari and Uttara Tantra. Okay, the medicines from Ayurveda have been mentioned in these books. He is the pioneer of synthetic drugs, distillation and cancellation. We use the words now. Okay. At that time, they were using batti for distillation. Batti distillation. Now also in Kannada it's there, but you are not familiar with Kannada words. Okay. So he had special interest and knowledge on iron and mercury related compounds. I mentioned they were using basmas, mercury basma, oxides of mercury, oxides of lead. They were being used as medicines. Coming to modern scientists' contribution, so one of the scientists that comes in front of his eyes is Sir Jagadish Chandra Bose. Jagadish Chandra Bose. He covered vast field of science, botany, physics. Many of the times he was mistaken as a botanist. Actually, he's a physicist. Okay, but he covered the vast areas, and he proved plants have life by connecting a root of plants to an instrument, and that visuals were shown on the screen where plant died when it is treated with bromide solution. Okay. He worked with British scientist Raleigh in Cambridge University. In India, he worked in Presidency College in Calcutta. Invented mercury coherer instrument to detect radio waves. This coherer equipment was further modified by Marconi, and he developed radio. Okay, and he got Nobel Prize and patents, but he never went for patenting. Swami Vivekananda suggested him to go for patenting. Somehow he was reluctant. He don't wanted patenting. He wanted all of his knowledge to be open to the society. It should not be restricted to a particular set of people. Okay, but somehow that was I don't know whether I can say misused. There was one story that when he went to Britain, he lost his notebook, what he had written, not this book, this kind of book. Okay, he lost his book where he had made points in that book. Okay, how much true? There is no evidence, but there is a story in that. That is connected to this development of radio by Marconi. Okay, Bose invented the diodes, which was honored by Royal Society for his research on electromagnetic radiation. So his contributions are immense for Indian science and also world science. C.V. Raman, in next 3 days we are going to have what? National Science Day. Okay. So what it signifies? What it signifies? No, C.V. Raman's birthday is on 8th November. He got Nobel Prize in 1930 in the month of February 28th. Okay. So his contribution in terms of Raman effect is very well known. Who are studying physics are studying Raman effect. Okay, this has helped us in identifying materials. We use Raman spectra to characterize materials. Okay, so it's very immense contribution to scientific world, not only to India, to the world, because we use Raman instruments, Raman spectroscopy across the world for characterization of materials. Okay, so the Raman effect, what he published, and that was recognized by the Committee of Nobel Prizes. He got a prize in 1930, and he established Raman Research Institute in Bengaluru, and that is doing well. We have heard of this name, Homi J. Baba, Homi Jahangir Baba. He is a well-known nuclear scientist, physicist and nuclear scientist, founding director and professor of physics of Tata Institute of Fundamental Research, TIFR. Okay. He is known as father of Indian nuclear program. Okay, he initiated nuclear programs activities in India, so he is known as father of Indian nuclear program. Okay. Similarly, another major contribution in recent times is Srinivasa Ramanujan. He has lived only for 30 years, 33 years. 33 years. If you publish, 100 articles, now it is very big for us, research articles. He has written more than 4,000 original theorems in mathematics. More than 4,000 in 33 years. He has died because of illness. 33 years he has contributed so much. Okay. And still his theorems are being studied at this point in time by mathematicians. You can look into various number of people are still publishing research articles on studying Ramanujan's theorems. Okay. And its application to various fields. We all know Saram Vishweshwaraya, Mokshagundam Vishweshwaraya, right? He lived for 101 years. He was Diwan of Mysore, chief engineer of state of Mysore. Before that, he was chief engineer in Bombay presidency. So, what is his contribution? First comes to KRS Dam. He is the major, architect of KRS Dam. And similarly, majority of dams in India which were constructed during that period, 1930s to 1960s, he was having brain behind those dams. Okay. Mysore soap factory, which is in Bengaluru near Yeshwanthpura. Okay. He has started. Jayacharajendra Polytechnic Institute. Okay. That is there in Bengaluru near KR Circle, UVCE. Okay. And then University of Agricultural Sciences near behind this. Okay. So he initiated that. And then in Bhadravati we have this Iron and Steel Works Limited. He started this. Why he did this is he realized that industrialization is very important for economic development of the country. That is how we started a lot of industries, and irrigation contributed by construction of dams. And in Hyderabad, he constructed one floodgate to Musi River, which has caused heavy destruction. This is a bridge that actually collapsed here because of the flood in Musi River. There, one automatic wear gate he has established, which was patented in his name. He also designed a plan for road construction between Tirupati and Tirumala. Right, you have to climb the hill. For that, road was planned by him. He played key role in developing systems to protect Visakhapatnam port from sea erosion. Okay, that is also his contribution. He served as chief engineer of Mysore State and Diwan of Mysore State between the period 1912 to 1919. Venkatraman Radhakrishnan is a space scientist from India. Of course, he studied in Bangalore from Central College, Bangalore University now. Okay. He was also a member of Royal Swedish Academy. So, what is his contribution is he studied about pulsars. What are pulsars? What are pulsars? See, in stars, nuclear reactions will be going on. Okay, this is the neutron stars that provides pulses of light in very fraction of seconds, microseconds to 1 second. Within that time, this periodic release of the light will be there. So that kind of lights we call them as pulsars. Okay. So understanding pulsars in stars helps in understanding the structure of the galaxy. So he also worked on interstellar clouds, mysteries regarding celestial bodies. Okay. And he studied the polarization of radio waves, radio interferometers, and with his team, He saw Jupiter's magnetic field and the root cause of anchoring of these moons of Jupiter. He used 21 cm line for understanding atomic hydrogen and its physical conditions in the galaxy. So this atomic hydrogen, neutral atomic hydrogen, when exposed to heat, it will liberate this 21 centimeter wavelength energy. That line was helpful in understanding the velocities in the galaxy. Okay, movement of light, the velocity of the light in the galaxy. In turn, the calculations were made about the age of stars. Okay, so that way it was helping. S. Chandrasekhar is another Indian scientist who was astrophysicist who spent most of his life in United States. Indian, but stayed in United States. He got the 1983 Nobel Prize for Physics along with William Fowler, okay, for theoretical studies of physical processes of importance to the structure and evolution of stars. Okay, so he began to study physics at the age of 14 at Presidency College in Madras, now Chennai. In 29, at the age of 18, he wrote one article, The Compound Scattering and New Statistics, scientific article, at the age of 18, where today's kids are grasping just 10 plus 2. Okay, at that age, he started writing. Received a PhD degree from Cambridge University, prestigious university, at the age of 22. Such a brilliant guy he was. Okay. He worked on famous the Chandrasekhar limit. In his name, there is one constant. In interstellar calculations, they use this, the Chandrasekhar limit, to determine the fate of stars. Stars will have nuclear reactions where energy is emitted out. Okay, there is outward, exhibition of energy, outward pressure from the nuclear reactions and quantum effects. Outward pressure is there. Gravity is pulling the star inside. So this will be in a particular proportion for very long time. When I say time, it is millions of years. Age of stars. Okay? But over the period of time, the fuel inside the star starts decreasing because it is consumed for over a very long period of time. When this fuel utilization is more and it becomes less, the quantity becomes less, the outward pressure from inside to outside pressure decreases and inside pressure overcomes that. This becomes more predominant, inside pressure. He predicted one ratio when this mass ratio to the original one when it goes to 1.4, the density of the material is somewhere 10,000 kg per cubic centimeter. Such kind of high dense material it becomes. That means this will shrink. This star will shrink. So at one point in time, they will collapse. Okay? That point in time where it collapses, what is called as Chandrasekhar limit, and the number is 1.4. Okay? That is the mass ratio. Okay? He won private appreciation from eminent physicists like Pauli, Bohr, Paul Dirac, who agreed with his calculations. Many of them opposed, his own colleagues opposed, but these scientists agreed upon his calculations in private, not in public. This kind of prejudice. Okay. So such kind of work he has done, that has resulted in understanding of galaxies in a better way by physicists. Going back. Satyendranath Bose was Indian physicist, specializing in theoretical physics. He is known for his quantum mechanics in early 1920s. Okay. Later on, Richard Feynman, you have heard the name Richard Feynman. He is again a physicist who has done extensive work on quantum mechanics. Okay. So now without quantum mechanics, today's modern gadgets what we are using wouldn't have been possible. We wouldn't have used those gadgets if we had not understood the quantum mechanics. Okay. Such complex phenomena is utilized in developing the technologies, modern day technologies. Meghnad Saha is astrophysicist known for the development of Saha ionization equation used to describe chemical and physical conditions in stars. This equation, Saha equation. This describes the degree of ionization for any gas in thermal equilibrium as a function of temperature, density, and ionization energies of the atoms. Okay. As the last scientist I am going to cover, I kept it at the end because somehow after listening to this person's achievements, I had very fond of his achievements. Yella Pragada Subbarao. Have you heard? So this is what happens in our history, who has contributed immensely, whether it is any field of life if you take. We don't remember. Some of our history don't record the right information. Okay? He is from Andhra Pradesh, Guntur district. Okay, there is one Bhimavaram village is there. From that place is very poor background. He took help of his relatives and some charitable trusts at the time, okay, and studied. He joined Madras Medical College. See, he was outstanding student. He was a black guy, Indian. We call ourselves black. We don't need to be inferior, but we were being treated earlier, even in sometimes in modern world. He was very good at writing examination. He joined that medical college and he wrote very well. But this fellow, Bradfield, had prejudice because this fellow is from India. He's a black guy. Okay. He didn't give good marks. He didn't award this MBBS degree. Rather, he awarded LMS degree. So, which is considered lower degree than MBBS. LMS is licentiate medicine in medicine and surgery. At that time, they were using this. But he did very well. Later on, he joined one of the Ayurvedic college and took interest in Ayurveda along with that. And later on, he moved into as a biochemist. He started working on molecules rather than medicine and surgery. But these molecules, drug molecules, he explored more and more. So, what are the kinds of drug molecules he has discovered is amazing. Okay. So after this, sometime he moved to US, where Harvard School of Tropical Medicine, and then he managed 2 to 3 jobs in a day because he wanted to earn, at the same time he wanted to explore the medicines. Okay, so he did a lot of work in 2-3 jobs, and finally arrived at many drugs. One is first contribution is estimation of phosphorus in body fluids and tissues. He worked along with the scientist Cyrus Fiske, and we have this Fiske-Subbarao method. You might have heard of, or you might study in masters. Fiske-Subbarao method is one of the colorimetric estimation of phosphorus. Okay. So that method was developed by him at that time. He lived just 53 years, 1895 to 1948, very short period of time. Within that period, he has achieved so much. He discovered a physiology in body, that is ATP heard, ATP, adenosine triphosphate, not heard. It is there in PUC, ATP. Energy in the body, how it is generated? Commerce also, you didn't tell. I thought everyone is okay. There is nothing wrong in learning about the Indian scientist contribution in the earlier era. Okay. How many are there like that? Thomas? Maximum. Okay, I would have come with numbers then. Okay. I have come with some 10, 12 numbers. Okay. He discovered, phosphocreatine, an enzyme in the body that breaks down ATP, adenosine triphosphate, to liberate energy in our body. Okay. He identified those things. And in 1940s, he joined, Leatherley Laboratories in America. He became director of that. Okay, that institute. And why he became director in that laboratory is because he was denied faculty position in Harvard University. That is why he went to this lab. Okay, but he didn't stop doing the research activity. He discovered more number of antibiotics. Antibiotics first, always it comes to what is that? Penicillin, 1928, Benjamin Franklin, right? But more than that, he discovered more number of antibiotics for different range of diseases. One of was polymyxin, which is still used in battlefield, okay, for curing diseases. Folic acid, everyone knows. Whenever you get iron deficiency, doctor prescribes this, right? Vitamin B9. He is the one who separated folic acid and purified that molecule, used it as a drug for anemia. Okay, he was able to cure. You just imagine now every female, if I'm correct, they will consume this folic acid. Iron deficiency, that is a common term. You will understand. Okay, so doctor will give you take iron tablets. Okay, what is there in that? This is the vitamin B9. Okay, when it was 1930s, 1940s, he has worked for identifying this molecule. And this cancer drug, anti-cancer drug, methotrexate. Few more minutes, I will be completing. Methotrexate is very important drug. After 70 years, or more than 70 years, it's close to more than 80 years now, this drug molecule still we are using for treating cancer patients. Chemotherapy. This is the drug. Till today we are using this drug. How many lives have been, quality of life of patients have been improved with his contribution. Anemia patients, how many are there in the world? How many patients, cancer patients are there in the world? Okay, there is another one, what they call in Kannada, Anekal Roga. Okay, this one, where is it? Filariasis, it's also called as elephantiasis. Okay, there the leg becomes very, become like, elephant's leg. Okay, that disease has been treated by this hetrazine, where it was discovered by Subara. Okay, still now World Health Organization prescribes this drug. Okay, hetrazine. Under his directorship, another scientist, his fellow colleague, Benjamin Duggar, he found this tetracycline antibiotic, ariomycin, few more drugs. Then another medicine that he discovered was isonicotinic acid hydroside, an effective cure for tuberculosis. We are using, till now we are using this drug. Okay. Millions of patients have been cured by these drugs. That is the contribution of Subbarao. I don't know if he was rightly recognized how many Nobels should have been given to this person. Unfortunately, world didn't recognize his efforts. Okay, but this institute, American Cyanamid, they honored Subbarao by giving a fungus the name as Subbaromyces splendens. If some microbiology students are there, you can explore now. Okay, Subbaromyces, a fungus name was given by his name. And that was the honor given to him. For you, science graduates. Lot of institutions are there in India. Okay, look into that. Joint admission test you have to take if you are BSc, JAM. Okay, if you clear, you can get into these institutes. Okay, they have done lot of contribution to to this nation. Earlier you listen to this talk by scientists from Riyadh. Okay, I am fortunate to work with them. The other lab of Riyadh by the name Devil. Okay, there are national science academies and then national institutes are there where you can take admissions in those institutes, and those become. We have a lot of high-end Indian Institute of Management. You should get into such kind of institutes by focusing on your studies to get into those kind of institutes. Okay, contribute to the growth of this nation. In 2017, India became an associate member of European Organization for Nuclear Research, and we are developing facility now. Okay, now near Chitradurga one installation they are going to make concern to this. Okay, to study the nuclear reaction. What are the opportunities for students? Look at this graph below. This is the number of quality researchers India is producing in compared to China and USA. See, if we are producing one researcher, China is producing 7.24. They are having 7.24 times. This is 2018 statistics. Now it might be more. US is having 17 times more researchers than us. Do we need to feel bad for it? I don't think so. Because this gap, what is there, it is available for you. You have to fill that gap. So work towards it. India is, huge population is there. To meet the demands of this big society, lot of scientific contributions are required, where you are required to fill those gaps. In whatever the field you choose, still there is a scope to fill that. Okay, space they have created for you. Okay, I will end my talk with these some of the contributions highlighted for you. To summarize what I spoke in the last 1 hour, what did I do? Okay. Science and scientific temper is human gene. So we all have that scientific temper. Necessity has driven us to do research activity to find the lot of comfort, what we want. So initial development in agriculture and utility tools have driven humans to find new comforts. Great number of ancient Indian scientists have contributed to scientific heritage of India. Indian scientists in modern era have stood to today's challenges. In the recent time, last year, we have seen how we have, worked with scientists and the governments, in solving this COVID problem. Vaccines within a very short period of time we have come up with, vaccines. Whether it is private or, from a government organization, we should be feeling proud. So this leaves us to appreciate the efforts of contribution of Indian scientists and follow their footsteps. Okay, so we should feel proud of their contribution. A lot of challenges as well as opportunities lies ahead of today's generation. In front of us, a lot of challenges are there. At the same time, we have opportunities as well. The critical thinker will always look at opportunities. Look at the challenges as opportunities rather than problems. When you face problem, you consider that problem as opportunity rather than a problem. Okay? So with this, I will end the session. Just 1 minute, I will take time to talk about the programs, what we are offering in our Faculty of Mathematical and Physical Sciences. We offer BSc programs in Chemistry, Physics, Mathematics, MSc programs in Chemistry, Physics, Mathematics, PhD, programs in chemistry, physics, mathematics. And the research work in our department, chemistry department, we are working on nanomaterials where a lot of semiconducting nanometal oxides have been synthesized, for battery and supercapacitor applications. These nanometal oxides also have been used for wastewater treatment and targeted drug delivery systems. Green materials have been produced, new molecules of drugs and monomers from biosources for making polymers, polymer composites for wastewater treatment, to remove heavy metals and toxic dyes from the wastewater. We are using these green materials. Natural products, synthesis are going on. And this project, polymer composites for advanced military application, where I am working with DRDO to produce a prototype of highly thermally conducting tube is required for their application in battle tank, which can be extended in submarines and space applications as well. To make the soldier comfortable when he sits in the battle tank. Otherwise, in terrain conditions like Pakistan border, the heat stress will be very high. At 55 degrees, soldier cannot sit 15 minutes within the battle tank. He has to come out. But in a battle scenario, he cannot come out like that. So extended time he has to sit within the battle tank, where his comfort levels are very important. If too much heat is there, a lot of dehydration it will lead to. If too much of dehydration is there, our brain reflexes will go down and he cannot act upon enemies. That problem is there. To solve that problem, we are working on to develop thermally conducting flexible tubes that can be embedded into the jacket to provide comfort to the body. So polymers in 3D printing, polymers for OLED applications, solar cell application, and high energy materials for military and space applications. Right now we have 4 projects going on. One from DRDO, 2 from Science and Engineering Research Board, 1 from Ramaiah Group funded project. So 4 projects worth 1.5 crore is being executed at our department. So with this, I thank all of you.